24 volts of direct current electricity are wired into a jar containing a solution of sodium sulfate. This chemically changes the water into hydrogen gas and oxygen gas, which are forming at the stainless steel electrodes. Notice on the left, there's twice as many hydrogen bubbles as there are oxygen bubbles, maintaining the 2-to-1 ratio of H2O. The gases travel through the hose located at the top of the jar and are collected in the soapy water on the left. Hydrogen gas is a very flammable gas, and oxygen gas supports fire. When these gases are ignited, they react in a violent explosion.
Let's electrolyze the water. We'll have cheap energy. Let's electrolyze the water. We'll have clean energy. The electric current disassociates water molecules into hydroxide and hydrogen ions. In the electrolytic cell at the cathode, hydrogen ions accept electrons in a reduction reaction that forms hydrogen gas. At the anode, hydroxide ions undergo an oxidation reaction that gives up electrons to the anode to complete the circuit and form water and oxygen gas. Hence, decomposing water into oxygen and hydrogen. When recombined in, say, an internal combustion engine, they make an ideal fuel to power our civilization. Let's electrolyze the water. I see it's all there in the sea. Let's electrolyze the water. We'll have so much energy. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Stan Meyer's dune buggy ran on water, hydrogen, oxygen fuel in an internal combustion engine, onboard electrolysis, no hydrogen tanks, no bombs on board, just water. In 1998 it ran 100 miles per gallon, the second best inventor of the century besides Tesla. Stan is now dead. He jumped up whilst eating a meal in a diner in Ohio, shouted, "I've been poisoned," ran into the car lot and died. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. By providing energy from a battery, water, H2O, can be disassociated in a diatomic molecules of hydrogen, H2, and oxygen, O2. This process is a good example of the application of the four thermodynamic potentials. The electrolysis of 1 mole of water produces a mole of hydrogen gas and half a mole of oxygen gas in their normal diatomic forms. A detailed analysis of the process makes use of the thermodynamic potentials and the first law of thermodynamics. This process presumes to be at 290 K and 1 atmosphere pressure, and the relevant values are taken from a table of thermodynamic properties. The process must provide the energy for the dissociation plus the energy to expand the produced gases. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving. That's what it amounts to. Molecules shaped by dance tune. Vibrations, that's what's happening. The space between here and there, moving.